Today our topic is triangle congruence by angle, side angle, and angle, angle, side. So our essential question, how can I prove triangles are congruent using sides and angles? First off, our two new congruence postulates and theorems. These are the last two for triangle congruence. We have angle, side, angle. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So we have to have angle, then a side, then another angle. So now the side is in between two angles. And then for our next one, angle, angle, side congruence theorem, if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So it's angle, angle, and then the side that's not in between the two angles. Here we have a little demonstration of angle, side, angle. So if you see this triangle, if we slide the two angles over with that side, the way that that triangle makes, you see how the triangle here, the shape right here, that is made with those two angles and that side length, that triangle will fit perfectly in that shape. So that is why angle, side, angle works. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. So if we look at our diagram, we have angle, angle, and this side congruent to this side. Then we need at least one more thing. We have to have three things, and if we look, we do have vertical angles, so we would have angle, angle, non-included side, angle, angle, side. So we would say angle, angle, side, and this is a congruence theorem. The next set with our umbrella, we have an angle, congruent, angle, and angle, 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 angle. We don't have one for angle, angle, angle. That does not prove that the triangles are congruent. We would need to know something about their sides. So no, they are not congruent. And then the last one, we have angle and this angle. We have a second angle. And then they share a side. So if they share a side, those sides are going to be congruent to both triangles. So if we look, we have angle, side, angle, angle, side, angle. So angle, side, angle, congruence. And that is a postulate. Prove the angle, angle, side congruence theorem. So if we are given that angle A is congruent to angle D, and angle C is congruent to angle F, and side BC is congruent to EF, we need to prove that triangle ABC is congruent to triangle DEF. So if we are proving this theorem, we cannot use this theorem in our proof. We cannot say, okay, well, we have angle, angle, side, so we just list all the congruent pieces and say that they're congruent, and then the triangles are congruent. We have to use other pieces to show why this theorem actually works. Why, if you are given two angles and a non-included side, does that prove that the triangles are congruent? All right, so we want to set up our two-column proof statements and reasons. We have all of our givens. We know that angle A is congruent to angle D, angle C is congruent to angle F, and angle, or not angle, side BC is congruent to side EF. We look at all that information. If there was a way we could show that these two angles are congruent, then we would have angle, side, angle, angle, side, angle. Now we know that triangles all sum to 180 degrees. So if we know that two angles are congruent, we know that the third angle is going to be congruent by the triangle sum theorem. So for number 2, we can say that angle B is congruent to angle E by our triangle sum theorem. And now that we have an angle, side, and an angle, we can say that the two triangles are congruent. So triangle ABC is congruent to triangle DEF, and the reason being is angle, side, angle congruence postulate. And that is the reason why angle, angle, side works, because it really just stems from angle, side, angle. In the diagram at the right, what postulate or theorem can you use to prove that triangle RST is congruent to triangle VUT? Explain. Well, we know that we have two sides that are congruent. We have two angles that are congruent, angle S and angle U. And then we can also say that these two angles are congruent by vertical angles. So angle STR is congruent to angle UTV, and that is vertical angles. So if we have a side angle and angle, that would be our angle, angle, side congruence theorem. So we have an angle. Oh, no, that's our side. We have a side, angle, angle, which read it upwards, it's angle, angle, side. And just listing out the congruent pieces is a good enough explanation, as long as you are listing them in that order. So, I mean, we did it backwards here, and that's fine. But you list the congruent angles, you list the congruent sides, and then you state that congruence theorem or postulate that you're using. Last piece is just kind of a summary box. These are the 5 different methods of proving triangles are congruent. They are the only 5. Otherwise, you have to know all the pieces are congruent to all the pieces. All the sides are congruent to their corresponding sides, and all the angles are congruent to their corresponding angles. So if you can't use side, 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 angle, side, hypotenuse, leg, angle, side, angle, or angle, angle, side, then we cannot prove that the triangles are congruent. So those are your 5 different methods. You will need to know those for your summative. That will be coming up after Thanksgiving break. So make sure you have those down. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.